numbers. And then like the simplest thing that's very easy to go through, and let's just start with that, is the points, right? What's the point? It's two integers next to each other, right? It's like x and y coordinates. That should be right. So I could say that. So what I want is, so let's start with an example. Points, right? A point is a coordinate in a two-dimensional plane, so on a two-dimensional plane. Right, so for example, 0, 0, 1, 5, etc. Right?
Yeah.
So I just assume that they're integers rather than numbers, with because it's just easier to talk about them.
Can I call them arrays or not?
Well, not really, because arrays implies that you can have more than two, right?
Yeah. Okay.
So it's literally only two parts. It's all the x and y coordinates, and that's it, right?
Yeah.
So we're going to call them points. Okay. So how do we define this? Well, it's very similar to what we've done before, right? So we do data, the keyword. We do point, which is the name that we want to do, right?
Yeah.
And then let's just say make point as the name for the constructor. Why not? Okay. And then we do int and then int.
Yeah, because it's two coordinates. Yeah. Okay.
Yeah, it's two components. Okay, cool. So let's kind of copy this and try to like replicate this idea again, right? I'll remove this line because we already know data is a keyword, right? So let's kill this, right? So then point is a new type that we just created, right? Make point is a constructor for point, right?
Yeah.
And then point, what do you think the type for point is?
Int. Oh yeah, it's also written higher up, but yeah, and it returns what? Does it return like a string or what?
Well, what do you think it returns?
I would say string, but I don't know.
Well, it returns a point. Yeah, exactly. It returns the new thing that we're creating, because otherwise we would not ever be able to create a. Oh, sorry. So I mistyped this. I'm sorry. It's make point, right? It's the constructor. Mm-hmm. Okay, cool. So then we can create following values, which is what? So mk point 0, 0, for example, right? Which would be like 0, 0, right?
Mm-hmm.
And then right? Does that make sense?
Yeah.
Okay, so let's try to let's see if so let's save here. So let's continue here, right? So let's paste this here, right? We have this. So then let's say origin. Oh, sorry. So okay, let me just mk point 0, 0, right? That's how we created them. Okay, so let's say I want to get x. So from point I want to get an int. And let's say that x is the first int, right? So when we type make point 0, 0, so let me do another example. So some point. So that means x is 1 and y is 2, right? And that's just because we want it to be like that, right? By our own definition, PureScript doesn't know what these things are, right? X and Y.
Yeah.
Okay. So do you think you can write get x here such that it gets the x axis from this point using pattern matching?
Okay. Wait. Let me give it a shot. So I get the get x. I still have to use the sum point. So.
No, you don't. No, it's so no. You are taking a point as a parameter. So maybe look at this as an example.
Okay. So the first line is already written.
Yep.
So here is what I would have to go for some point.
Still no. So it's the constructor name basically. You need to type there.
Make point.
Yep. There you go.
Yeah. Okay. My bad. And x.
Yep.
And it's equal to x.
Except
And now,
okay, go.
do I add 0 as well?
Well, not
Or,
there, not there.
What?
So the thing is, so it's correct to type x here, but then here, make point requires two things, right? So you just type a y here that you just won't use. And usually when we have parameters that we don't use, we can put an underscore there just to tell everybody, okay, this is not used. Something should be here, but we don't care what it is because we will not be using its value.
Yeah.
So we can put an underscore there.
Mm-hmm.
Okay. Does that make sense?
Yeah. Okay.
Okay.
So I was actually using not the constructor name. Yeah. I
Okay.
got it.
Cool. So can you type get y now?
Yeah. Get y is get y, just the same, except it's the make point.
Yep.
So we don't forget. But now it's underscore and y.
Exactly. So the position matters, right? This is positional, right? The first one's the x, the second one's the y. So the position matters, right? So because then like a wrong way to do it would be to type y here and then this.
Y and underscore.
But that doesn't. That's the same as x, right? It's just that you name it differently, right? Because PureScript can like allows me to type here like whatever, right? And I could do whatever here, and that's totally fine, right? It doesn't know what. Well, like this, right?
Yeah.
Okay. Cool. Cool. So we're good now. Okay, so what kind of other things can we do? Like maybe do something else here. Okay, let's do one more thing, and then we can go to the next thing, the next example. So let's say I want to increment x by 5. So increment. Okay, so I'm taking a point parameter, right?
Yeah.
And I want to increment
Add
his
the first coordinate.
okay, but I want to also return a point. So let's do it piece by piece. So how do you like? What's the plan here?
Maybe it's not correct, but the first thing I would do is that I would just create a function that adds 5 to x, and then I would call it in the make point. Is that okay, or is that like a harder solution?
It's probably hard. So let's start at the beginning. So first thing, what do you want to do? We want to grab the values for the input point, right?
Yeah. So I would go make point, right?
Yep.
Okay, make the point. So I would have x and the underscore actually. But is it okay if I just say +5? Like this?
No, because here it would pattern match with like this won't even work. It would be a compilation error. But even if you could write it, this would be the pattern match region, not the evaluate. Like you can't write code here basically, right? This is just for pattern matching.
Oh, okay.
So it has to be on the right hand side of the equal sign.
Yeah. So basically, if it would work, the first coordinate, like the x, would be x +5, right?
If this would work, yeah. So if this were to work, but it doesn't because you cannot pattern match on like arbitrary functions, then it would basically the semantics would be that it gives you an x that's 5 smaller than the actual x, right? It would be like something +5 would be the actual x that's in here.
Yeah. Okay. Got it.
Okay, so let's remove this part and let's try to do an equal sign then, right? Because we need to write the definition.
Equal. And
so then we need to return a point. So how do we create a point?
Well, do I just create it again?
Yep.
Like the make point.
Yep. That's what we need to do in functional programming. Okay.
Except, so it's the same like this.
Well, okay. So first off, this is where we realize that we cannot use underscore here because we need to name it, right? So we kind of need to use y in both places. Hey Daria, welcome. You get it, right? Because like if you do like what happened if I had the 3D coordinates and there would be 2 underscores? How the compiler know which goes where?
Okay, yeah.
So you basically you can do this. You need to actually write down the y in both left and right hand side.
Yes.
Okay, cool. But so what's happening now is that we're returning the same thing that we got as input. So we need to increment by 5, right? The x.
But I don't know how to do it because my first thought would be to do this, but I don't think it's correct.
That's not correct, right? Because just replace x with 5, right?
Yeah, so that's correct.
No, this just replaces it. So I want to add 5.
Yeah. That's what I said. Yeah, okay. So I don't know how to actually.
You're probably overthinking it. It's just x +5 here as in parentheses. right? It's the simplest thing that you could imagine.
Okay. Okay, so it's what I did here, except it doesn't work here.
Yeah, exactly. It has to be on the right-hand side, not there. Okay, so this is a pretty important point in functional programming. There's no mutation, right? You cannot say p.x plus equals 5 or whatever, right? Like you do in C# or whatever. You can't mutate the value. So you need to deconstruct and then reconstruct with a different value. The good news is that functional languages are usually pretty fast at doing this. This isn't necessarily 100% the case for JavaScript, because JavaScript, and this compiles to JavaScript, so doesn't necessarily mean that this is very fast in pure script, although this will rarely be your bottleneck in an application. But in languages like Haskell, this is very well optimized to, like, this works pretty fast. Things like this, like unwrapping and unwrapping again.
Okay.
So it's usually not a performance problem in having to do this. Okay, cool. So we got an idea of how. Wait, what's this? Oh, okay, we need to import prelude, because the plus operator is defined in preludes, right? So it doesn't know what plus is until we import it. Wait, can the PureScript compiler do that? I don't think the PureScript compiler does that. Like, I don't think it decides to do mutation. Maybe GHC could do that, but it could. Okay, sure. Yeah, so you don't know what this code gets interpreted to by the compiler, right? The compiler could do mutations. It actually doesn't, but it could, right? But it doesn't matter. That's like a very, very low level implementation detail. Okay, cool. So we've seen how we can play with like product types. And okay, I want to talk about something, I think. Yeah, I want to talk about something before we go further that I should have talked about here. So let's go back for a bit, right? So we kind of said that let's do a small, after what are types, let's do a small detour to types as sets. Right, so like I kind of said that for example, like we could consider like Boolean set and its values along with its values, right?
Yeah.
You kind of remember what a set is from math, right? It's kind of like it has a name, right? So we can say something like B equals to true and false, right? That was the notation in math for sets. Cool. Mm-hmm. So then we could say that, like you remember, like and the natural numbers is 0. Well, it's then this is more like like z, I guess, right, for ints, right? So it's minus infinity, and then like minus large numbers, and then 0, and then 1, and then plus infinity, right?
Yeah. Sorry, my voice.
No problem. Right, so. And then strings, again, we can think of like the empty string, and then the one character, and then AA, and then etc., and then AB, and like all these, like a lot of strings and so on. Okay, so then one concept from math, which so do you remember the concept of what was it called? I'm drawing a blank here. What was the name for the cardinality? I think is the name. Yes, right. Okay, go ahead.
No. Is it like the number of elements in the set?
Yep, exactly.
Okay.
Perfect. Right. So the cardinality of a set, and I was drawing a blank there for a second, is the number of elements of that set, right? So for example, and we usually write it like so, right? So in like this thing, right? So B is 2 because we have 2 elements in B, and then Z is infinity, and so on, right? But then, for example, we could define weekdays is Monday, Tuesday, Wednesday, Thursday, Friday. Why can't I do it? Saturday and Sunday, and then weekdays is 7, right?
Yeah.
And so on, right? We can define whatever we want and get the cardinality for it. Okay, cool. So when we do something like this where we wrap a single value, the cardinality should be obvious. It's the same as the thing inside it, right? So if Boolean has 2, then create my bools also has 2, right? So the is 2 just like bool, right? That should be pretty obvious. Okay, so what do you think the cardinality is here? Do you want to take a guess? So what's the cardinality? So how do we say this? So first of all, when you do this, okay, let's do just point for point, right?
Yeah.
So do you have a guess?
No, I mean, wait. So I'm thinking about the set of points that I'm creating the product. So I think it's. I mean, it can be infinite. But
okay, so it's definitely infinite because.
But what I created is 1, right? Because I only created 1. If I'm not mistaken.
No, it's fine. Because okay, so what we're thinking about is not the values that we created so far, like these 2 values. We're thinking about what are all the possible values that we could ever create using that could live inside the point, right? Inside a point type. So they are indeed infinite, but. So let's say, okay, this is a bad example. Let's do a new example because this is infinite, of course. So, 2 bits. Right, so we hold 2 booleans here.
Now I get what you're saying. So it was only with 2 values. So I can have false, false, true, false. Like they alternate, right?
Yep.
So
but I could also have false, 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 true, true, false, true, true. So how many do you think there are?
And
you can write them down if you. There you go.
FT. So it's also TF.
Yep, of course.
What the hell? Am I dropping something? Is it 4?
Yep, it's 4. That's all of them.
Okay,
cool. So it's 4, right? We can actually keep that because that's a good. Okay, so let's say. Let's say I do this.
Okay, so. This is the. Is this the? I mean, in Romanian it's aranjamente.
Probably right? Some sort of combinatorics. Yeah, you can think about it like that.
Arrangement of 3 selected by 3. Like this is what it sounds like in Romanian, I think.
Sort of, but okay. So there's a simpler formula here than doing that. So what this turns out to be is basically it's a product, right? So if you think about booleans as being 2, right? And then this boolean as being 2, this boolean as being 2, it's the product. That's the answer, right? So it's 8, all the possible values.
Yeah.
Right?
Yeah.
So basically, what the general rule is that. So let's see, the general. Okay, so let's first say that these types are called product types, and they're called product because one of the reasons is because the number of possible values is a product of their like sub values, if that makes sense.
Yeah.
Right. So the cardinality of such a type is a product between its, let's say, components. Right.
Yeah.
And then same goes for numbers, right? So even if you have 2 points here. And even if we're talking that, okay, there's infinity, but let's say if these were bounded, like if these integers were 32-bit integers, right, and no bigger than 32-bit, then this would hold like 64 bits, right, because it's twice that much.
Yeah.
Right. So okay, in math, if we consider this to be infinite, sure, it's also infinite, and it's I think it's just as big. I think two integers are just as big as one, with infinities. But again, I'm not a mathematician. I might be getting my infinities wrong.
No, you might be right here. Yeah. So it sounds good.
Okay, cool. Yeah.
Okay, so Yu-Gi-Oh said that it's permutation or orderings. I think it's permutations.
Yeah, I think so. I think it's permutations, but yeah, that's the simplest way to think about it. It's just a product. It's a lot simpler. Okay, so let's try getting into functions now for a bit. So we were kind of stopping here for a minute. Okay, these are products. You should be familiar with products because you can also define products in C#, right? So whenever you do something like a struct in like a struct A that has a few fields, or a class or whatever with multiple like fields, then that's similar to a product, right? The idea is similar. Okay. Okay, so then we have functions, right? So functions are created. So we've already seen a lot of examples. Functions, right? Like show that goes from something from A to string, right? We used it usually for like for ints, but it can go from different things to string and so on. We've seen a lot of examples. So usually functions are okay. So let's see. In order to create a function, we usually use okay, functions are a type written usually as A goes to B, right? We've seen this, where A and B are where A and B are types, right?
Yes.
Okay, cool. So this is the function type basically, but we'll talk about the whole thing as a function type, right? So A goes to B, right? So how can we? Okay, so basically, if we want to, so we can write like int goes to string, or string goes to string, etc. Right? So these are like, let's say, okay. So these are unary functions, but we can also write functions with multiple parameters, right?
Yeah.
Parameters like int goes to int, which is like addition or multiplication or whatever, and like we've seen a lot of examples like string to string, etc. The trick here is that multiple parameter functions are actually encoded as, and this is the thing that it's really important to get. So let's use like this, right? So the parenthesis goes this way. Okay. If that makes sense. So let's look at what that means, right? So, for example, so what this means basically is that every function, no matter how many parameters it has, right? How they really work inside is that they want one more parameter and they return a function that wants one more parameter and then it returns a result eventually, right?
Okay.
So that's why we could say something like, let's go back to our example from the first day. So remember when we were saying something like, okay, let's rewrite the add three examples thing here. So let's do this thing here, and then let's do the add three numbers again, right? And then it's x, y, and z, and then x plus y plus z, right? This is the add three numbers. Right? Remember that, right? Yeah. Okay, so if I want to do add two numbers, then it's just two numbers go to a third one, right? To the result. Yeah. So the rightmost is always the result, right? So we have two parameters. And then we have m and n, let's just use different names. And it's the same as doing add three numbers, 0 of m and n, right?
Yeah. I remember this. Yeah.
Oh, wait, I just imported, oops. Why doesn't this work?
Want me to press something?
Yeah, never mind. I'll just type it again. Well, actually, let's just copy it from here because there's no point rewriting it. Add three numbers. Let's use this version.
The easy
The Vim. No. I copied it. The Vim bindings don't quite work properly in Visual Studio for some reason. So let's try this. Okay, so then we got two numbers.
And
X MN.
Yeah, and it's MN and 0.
MN and 0, right? And you should not do this because we already redefined it here. Okay, cool. But then we could just as easily do this, right? And I don't remember if I explained this to you. Let me think if I can. Okay, see you later, Yu-Gi-Oh. Okay, so let's see. Now, this is probably too complicated to explain right now. I don't think we want to go through this. So let me think how I can explain this better. Yeah, so the idea is, for example, let's go back here. So let's say we have the function. Let's copy this function here. Let's do something else because I have a better idea. So let's consider pure script. Let's do this here. Let's just call it it, just to make it easier, right? So this function is called it, okay?
Yeah.
So let's say it, what type has it? Well, you know, it's int to int to int to int, right? We already know that. Okay, so what type has it1?
It's int.
Well, is it int? Because we only pass it one parameter.
Yeah, I think it's, I might be wrong, but I think it's int.
It's so it's basically the same as this,
yes,
but with one less int.
Okay, yeah. So it's int.
Yep.
Oh,
wait, stop. Yeah, that's it. Right? It's one less. Okay, so what if I do it 1 2? What's this?
And now it just removes another one.
Yep.
So I only have 2 ints. Yeah.
Yep, and be careful. I know that you meant you have 2 ints here, but you basically need one more int to get an int as a result, right? Okay.
Yes.
Okay. Wait, what are you doing?
No, I don't know. I thought you deleted it.
No, I didn't. Okay, so let me type for a second. Okay, so we have this. And then if we do it 1 2 3, then what do we have?
We only have 1 int, which is the result.
Exactly, right? And it's like 6 or something, right? So what if I do this? What do you think this does? It's a trick question, by the way.
Okay, well, I think it doesn't put the sum of them. It just returns 1 2 3 4.
No, this is just an error.
Oh, no. Okay.
So this is a type error, type or compilation error.
Yeah. So
right, because like that doesn't make sense. What should I do when you put a 4 next to this result?
Yeah, it has no return. Yeah.
So it's like, okay, it's kind of like saying 6 4. Well, what the hell's that? Right? It's just an error. There's an operation missing or something, right? Okay, cool. And this works for any function, right? So any function that has any number of parameters, you can apply them in order one by one, and you just basically resolve one of the parameters one by one, right?
Yeah.
Okay, cool. So let's think about something a bit tricky now. Okay. Let's before we do that. So basically, there is no. How should I say this? So in order to write a function like we did here, where is it? So here we talked about, okay, so we have a point, right? A type.
Yeah.
And we can create points, right?
Yes.
And we can pattern match on points like we've seen in the exact code examples here, right? We can pattern match on points to get the like underlying things from, let's try to undo that. Okay, cool. Okay, so what about functions, right? So we will not be creating our own types, but we'll look at the default function type here, right? So let's see, how do we create functions? Well, we've already seen how you create functions, right? So if we want to create a function from f from int to int, like we've seen, we can do f x y equals to x plus y plus 1 or whatever, right? So this is how we create a function, right? We basically declare this sort of expressions or relationships or however you want to call them, where you declare a function type here, and then you take the arguments on the left of the equal sign, then you write an equal sign, and then you write the expression for the function, right?
Yeah.
But then how do we use a function? Well, we use a function by applying it, right? So we say f of 1 and 2 equals to 4, and that's how we use a function. Well, we don't, we just do this, right? And then it gets evaluated to 4. Right? So that's how we use functions, basically. We've already seen that.
Yeah.
Okay, so let's think about cardinality. Functions. Ooh, what does that mean? Well, functions are a lot like anything else, right? So first, let's think about it for a second. So let's say functions like Boolean to Boolean. Okay? So
can I make an assumption?
Okay,
Like,
go ahead.
The cardinality of functions is the cardinality of values that it can return.
Well, not exactly. So the cardinality is okay. Cardinality of functions is okay. So first thing, what does it mean to have the cardinality of a function? Well, it means what are all the different functions that exist of this type Boolean to Boolean. So how do we count these sort of things, right? How do you think about this? Well, you kind of like, okay, so the input is a Boolean. So, right, if I get the input true, right, what can I do?
True, false.
I can return true, or I can return false, right?
Yeah.
Okay.
So if I get false, I get true or false.
So I could do one of these things, right? If I get true, right?
Yeah.
Okay. Actually, let's think about it. How should we think about this? That's easy to consider. No, let's do something else. Let's do like function Boolean to Boolean, right?
Okay.
And just type pure script here, right? So we could do something like okay, let's do this, a truth table, right? So you can do fn of true equals to something here, maybe true, right? And fn of false equals to false, let's say, right? Okay, so what else can we do? So this is like fn1, right?
Yeah. And now it's 2. Yeah.
So here, what can we do? We could flip them, right?
Yeah.
Okay, sorry, and true here, right?
True, yeah.
Okay, is there anything else we could do?
Okay, give me a second.
So maybe we could try doing this as a table, right? Because it looks like it's sort of like a tabular thing, right?
Yeah.
So maybe we have something like, I'm not sure, let's see if I can remember how to do Markdown tables. So this is the input, and this is output. Well, no, let's do something else. Let's do output for true. Sorry. Output for false. And then let's do a name for the function, right?
Yeah.
Okay, and I guess that's it. So let's see, the name for the first function fn1, and maybe we'll give them better names later, right? And the output for true is true, right?
Yeah.
And the output for false is false, right?
False, yeah.
Okay, cool. And then we have fn2, which output for true is false.
False,
and output for false is true, right?
Yeah.
Okay, so what kind of
now I have to flip them again, right?
Well, if we flip them again, isn't it the same as the first one?
It's the same as the first one. So it's the function 3. No.
Sure.
Okay. Where is the top of it? What else can it be for true? Like we have true or false, can it return something else?
Um,
Or am I just being silly?
no, it cannot return anything else. But the thing is, like, we cannot have a different value here than the ones above. But like, it's important that per row they're different, right? So you can think of this as encoded as TF, and this is FT, right?
Mm-hmm.
So what's missing from all the possible things that could be with two booleans?
TT and FF.
Yep, exactly. So we can have, so nothing is stopping us to have a function that returns always true, and then at 4 always false, and just ignores this parameter. So how do this look like, right? Well, it's just this. Well, I lied. It's 3, 4. Okay, and then this is true, and this is true, right?
Yeah, I kept trying to alternate them, but the answer was really simple. Yeah, oh, yeah, my bad, yeah.
Okay,
sorry.
And then this, don't worry. So this is called identity, right? Because it gives you the same thing, like for true is true and for false is false, right? So it's just identity. This is not or negation, right?
Yeah.
This is const true, and this is const false.
Yeah.
Okay. Okay, cool. So there's 4 different functions that could exist for Boolean to Boolean, right?
Yeah. So
okay.
Does that mean that the cardinality is 4?
Yes, the cardinality is 4, but now we're trying to figure out what the formula is, right? Okay, so that would be TT and FF. Yep, TT and NF. Oh, thank you very much. I'm happy you guys are enjoying it. Okay, so now we kind of have to figure out. So until now, we kind of have the same idea as we have for products, right? It's kind of like, okay, so it looks like it's 2 or 2, right? It's maybe 4 because it's, but that's not correct for functions. So we need to dig a bit deeper. Okay.
Yeah.
Okay, so let's look at a different example. So let's say that we have a function that goes from Boolean to int. That's a lot harder, right? But let's just think how this would work, right? So let's say we have the same thing, right? But but instead of let's see. So instead of let's not worry about the name for now. So okay, what can we have for true? Well, we have numbers, right?
Yeah.
So we could have, for example, 0 and 1, right, or whatever. Let's say, okay, let's make it more reasonable, right? This is the simplest, the more reasonable function that we could have, right? So we return 1 for true and 0 for false, right? That's very it happens very often in programming, right? But then, like, nothing stops us from using any other number, correct?
Yeah.
So it kind of ends up being that we can have, like, nothing stops us from having both of them returning 0 and then both of them returning 1, but then both of them returning like 3 and 2 and 5 or whatever, right? There are a ton of different options here, correct?
Yeah.
Okay, cool. I don't think I picked the greatest example now that I think about it. Let's see if we can salvage this, or do we need a new example? So the example I usually use is 3 booleans, right? Bool to bool to bool. I was thinking if we can escape it, but I guess we can't. So let's forget about this number. This example, I'm sorry, this is not a good example.
Okay.
So let's do this, right? So so we have this thing changes now, and let's see if you can follow. So let's use FF, FT, TF, and TT for the possible outputs. So okay, what do I mean here when I type it like this?
When you get false, what's the third boolean that comes out of it?
So right? So these are the inputs, right? So when I get false, false, when I get false, true, and this is where I do the result, right? The answer for the function, right? Okay, so that's clear, right? Instead of 2, we need to have 4 things here, right? So instead of output for true and false, we need an output for all the possible combinations, right? That makes sense.
Yeah. So can we start with the simple ones?
Sure.
Where we just throw everywhere?
Sure.
And
So yeah,
false
we have. Let me. I'll just type just to make it so you can focus on talking, not typing, right? Okay. So this is const true, right? We already know what this is. Cool.
we
can.
have the const false as well.
Yep. Okay. I ate this thing here. Okay. I think we're good now. Okay. And then we have const false. Actually, I should have just copied it and replaced F with T with F. Okay, cool. Wait, what doesn't that work? T with F. Okay, there we go.
Okay, nice. Okay, so now there's also the possibility of having 3 true and 1 false, and the false keeps alternating its position.
Yeah, so there's a lot of options. Let's think of it like we have something like, okay, so let's see. We have true, false, 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 and then we have false, true, true, true. Well, right, and we can move the true through this like diagonal, maybe. Like we can have an algorithm to like think about this, right? How it goes. But then at some point, for example, we probably also have the like usual, because what is a function from bool to bool to bool? It's like the usual Boolean operators, right? So we can have and here at some point, right? Which is kind of it goes like if it's false, like it's false. I think it's already one of those that we already have. It's FFFT here.
Yeah.
Right, and then we have or, which is false, true, 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 right? And then we have exclusive or, and then whatever, right? There are like implication that there a few of them have a known name, right?
Yeah.
And some of them could be, for example, not or, right? Which is well, that's the. Which is like true and then false or over all the other, right? It's true, false, 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 and so on, right? So some of them could have interesting names, some of them could be just arbitrary, right? Well, not necessarily arbitrary, but just a number of them. Okay, so we could probably think about this from the sense of your intuition was actually not bad here when you were thinking about products. We could think about it as from combinatorics perspective, right?
Mm-hmm.
Right, so we have like basically you have four slots, right? 1, 2, 3, 4. And in each of these 4 slots, we could have 2 possible values. Yep, exactly, right? So then in combinatorics, this turns out to be something like 2 to the power of 4, right?
Yeah.
Okay, so how do we get here? Like, okay, what does this mean for our type, right? So what is this 2 and what does this 4 represent? So let's remember how we got from 2 and 4, right? So what's 2? Well, 2 is the return type, right? It's this Boolean, right? Because this is what we're returning. We're returning a T or an F because this is a T or an F, right?
Yeah.
And then why do we have 4 slots? Well, because this is kind of a product of 2 things, right? It's a product. Yeah. It's multiplication, right? So it's like because 2 or 2 is 4, right? This thing, which we know it's already a product.
So basically, it's exponential.
Exactly, it's exponential. So and this is 2 times 2 here, right?
Yeah. Mm-hmm.
Okay, interesting. So. Well, actually, we could even think about it differently. We can even say, since we know this is, but let's not go into that. So let's just do this. Okay, so that kind of means that the cardinality of a function is an exponential. So for a goes to b, the cardinality is b to the power of a.
Yeah, makes sense.
Right. And if you remember this example, right, where like with Booleans, where we make the truth table and it's like, okay, these are the like number of slots and this is the slot type, right?
Yeah.
It should be fairly easy to remember that it's like it's kind of reverse, right? Instead of A to B, it's B to A, the exponential. Okay, cool. And it's also quite interesting to think about it, right? Because like how many ways do you have to implement a function? Well, it's like basically there are only this many functions that exist for this type, right?
Yeah.
anything else would be just a duplicate of the existing ones, which is pretty cool, right? If you can think about this as long as you want, you will not never find a function that returns a different set of values for its inputs than this for bool to bool, right? That there just can't be any. Okay,
yeah,
cool.